Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's see how we did on our homework. Starting with the M&Ms, types of samples from a population. We actually got this written into our notes yesterday quite extensively, so you may not have had to write a lot of this down. I'm not going to go back over everything, but I would like to just focus on this cluster sample that we talked about yesterday. If you've got them clustered, like one cluster only has 8th graders and another cluster only has like 7th graders, then this is not a representative sample. But if you can take each one of these clusters and take a couple from the 8th grade, a couple from the 7th grade, a couple from the 5th grade, and make sure that you got equal numbers of boys and girls, then you are getting more representative of the entire school. So I stated of all these that the cluster sample would have been the most representative, but not just as the cluster of 8th graders. So it would have to be, equal numbers of each one of those clusters put into the sample group. Then it would become representative of the entire school. Okay, so let's check and see what we've got here. Suppose you were conducting a survey to try to determine what portion of the voters in your small town support a particular candidate for mayor. Consider each of the following methods for sampling the voting population of your town. State whether each is likely to produce a representative sample and explain your reasoning. So if you ask every voter on your block, that's a no, because people in your neighborhood may not have the same demographic as people in another neighborhood. I mean, all of you have seen some neighborhoods have really expensive houses, and the people that live in those neighborhoods have lots of land and lots of money, and their priorities would be different than people in another neighborhood on a different block where the houses didn't have as high of a value. So yeah, that is not really representative. Randomly picking one house from each block in the neighborhood and survey the homeowners. Well, I like the random part of it, but still, they're in your neighborhood. So that doesn't make it truly representative of the entire town. Survey each person at iJump Pancake Restaurant after church on Sunday morning. That's not really representative because you're probably only getting people who go to church. If it's after church, a lot of times people go out and have like a lunch or a brunch or something after church. And so you'll probably get a disproportionate number of people that are churchgoers, and they might have different priorities than non-churchgoers. For D, ask people who are leaving the twice yearly town hall meeting. Well, these people are active and they're probably voters, so in that respect, it's pretty good. But still, you're only getting people who are active within their community, who go to the town hall meetings. I've never once in my life attended a town hall meeting. I don't know if that's a good thing or a bad thing. I've just never gone to them. I get my information in other places. So you're not going to target all the voters there, and it wouldn't be a representative sample. I think E is the best one. Visit every 10th person, that makes it random, on the county's voter registration list. So the county's voter registration list is a list made up of people who regularly vote. And that's who you want to get information from, who they're going to vote for. It doesn't really do you much good. All these others, you might be getting people who never vote. And so it doesn't matter what their opinions are. You want the opinions of voters. So this one is going to be the best one. All right, now changing things up, calculate the percent change. Now you may recall, to find percent change, we would take the amount of change and write it as a ratio over the original amount. I'll abbreviate those. And so what do we have here? Robert wanted to buy a computer game that cost $25 last week, so that would have been the original amount, but this week he went back and it increased by $10. So that is 10 more than the original. So the amount of change was a positive change of 10 out of 25. So if we want to find the percent change, just set that up as a percent proportion, and you can see 10 out of 25. If you multiply that times 4, multiply this times 4, you're going to get that as 40%. Susan bought a jacket on sale. The original price was $35 and it was marked down to $25. All right, so here we've got a reversal. It's still a $10 change, but the original was $35. So notice how you don't have the same giant one here. You are not going to multiply 4 times 35 to get 100. So you can't multiply 4 times 10 to get the percent. You've got to figure out what you multiply times 35 to give you 100. And in this situation, I would probably just go with the, I'd probably just cross multiply and say 35x is equal to 1,000, and then 1,000 divided by 35. Oh, goodness gracious. Let's move you out of there. 1,000 divided by 35 gives you this. So that ends up being rounding up, ends up being your percent, 28.6, when you round that to the nearest tenth. Why were your answers different? Well, notice it's the percent change is always based on the original amount. Here, the original amount was 35. Here, it was 25. So if you have different starting amounts or original amounts, it's going to create a different ratio, which is going to have a different percent. All right. I suppose we might have time for me to go through and do each one of these. They're all involving division. So I'm going to take 12/5 divided by 7/10 and rewrite this as 12/5 times the reciprocal, and then multiply straight across and simplify along the way. If you want to simplify it beforehand, you can cancel out the 10 and the 5. They have 5 in common, so this becomes a 2 and this becomes a 1. If you don't want to do that, you don't have to. You can just multiply straight across and then simplify that fraction to its simplest form. Here, we're going to multiply times the reciprocal, and because it's a positive divided by a negative, you're going to get a negative answer. So I'm just going to treat this as, what does that become? 27/4, but we know it's going to be a negative, so I'm going to put that negative sign in because this was technically going to be -3. And then the last one, it's a negative divided by a negative, so you end up getting a positive answer. You get -3/5 times -6/1, so that ends up being +18/5, which all of these, by the way, could be changed. I just wrote them as their as an improper fraction, but if you've got them written as mixed numbers, these would be the answers. And if you've got them written in decimal form, that one is the only one that's going to be repeating decimal. This would be -6.75. This is +3.6. Ooh, I remember these problems. Yeah, find the area and the perimeter of each of these shapes. Well, finding the perimeter, let's just go ahead. I'm going to highlight this in yellow. Anytime you find the perimeter, you need to add up all of the sides to get the perimeter. And that means you need a side length right there, which we know is the 30. So 13 plus 13, what is it? 4 13s. So that is 52 plus 30 plus 30 gives you a total of 112. Here, you know this is 80, you know that's 50, you know this is 12, this is 5, this is 8, this is 5, this is 12. Since this is 14, makes this 14. And so you add all those together and you get 186. All right, now for the areas. The area is really the part of this that's pretty complicated. What you've got here are 2 trapezoids. So we're going to take the formula for a trapezoid, which says that the area is going to be basically the average of your 2 bases. So you take base 1 plus base 2, and you find the average of those 2 by adding them together, then dividing by 2 or taking half of it, then multiply times the height. So in each of these cases, what is base 1? 30. And base 2 is, what is that? 12 plus 30 plus 12 is 54. Take half of that. So what is half of 84? Is that 42? And multiply that times 5, because that's the height. And 42 times 5 is 210. That means that this is 210, and since that's a mirror image, this is also 210. So you put them together, and you get 420 square units. For this one, you've got a couple of different approaches that you can take. One is you could find the area of this triangle and then find the area of this shape and then add them together to get your total area. Or you could treat this as a big, I'm going to get rid of, no, I don't want to get rid of that. You could treat this as a big trapezoid, and you're only going, and you're going to subtract this area right in here. I think that's going to be the approach that I take. Since this area is a 5 by 8 area, that means we're going to subtract 40 from the overall area of that trapezoid. So what are the dimensions of this trapezoid? Base 1 is 80. Base 2 is 12 plus 8 plus 12 is 2032. So we take half of that and then multiply times the height, which is 14. So what is half of 112? I think that's 56. And then we multiply that times 14, and let's see what 56 times 14 equals. 56 times 14 is 784. So remember, that's for everything here, including this little section that shouldn't be there. That's the 40 square units. So we're going to take 784 and take this section away, which leaves you with 744 square units, which is our answer. So some of these complex areas that you have to find, sometimes you add up, you find the area of the individual parts and you add them together. In other circumstances like this one, it might be better to find the area of the larger shape and then subtract away whatever part you don't need, which is what I did there. This problem, this is absolute value inequalities. We used to spend a lot of time on these, but apparently now it's relegated to a couple of problems in homework. I'm not crazy about that, but maybe it just doesn't come in. Maybe it's not very common math to do. So let's just read through this problem. The recommended speed on a scenic road is 35 miles per hour. Driving too fast is a hazard, but so is driving too slowly. So the safe speed, which is S, that's our variable here, may be described by this inequality. The absolute value of your speed limit minus whatever your speed can have no greater of a difference than 10. So if you just think about this logically, this is actually a lot easier to solve logically than to solve mathematically, but I'll show you how to solve it mathematically. It's just you can go 10 above or 10 below. So what's 10 above 35? 45 miles per hour. What's 10 below? 25. So find at least 5 safe speeds. Well, you can choose any speed that's between 25 and 45 miles per hour, and those would be considered safe speeds. Okay. So in order to solve this problem, let me move this. Stop it. Move this guy over to here so I can use this space. We have, when you have absolute value inequalities, that's an S there. It's less than or equal to 10. What we do is we take a positive and a negative equation or inequality out of this. And this is the part you have to memorize it, and it's not easy to remember. So if this seems really complicated for you, it's not complicated. It's just one more thing that you have to remember to do, and that's what makes it complicated. So the positive inequality for this situation is to take 35 minus S and make that less than or equal to 10, exactly how you see it here. The negative means we're going to take 35 minus S, and we're going to change each one of these, both the inequality symbol and the number, to its opposite and make it greater than negative 10. So now when I solve each one of these, I'm going to, what should I do here? I'm going to add S to each side, which cancels out the S here, but then we add it over here, and then I'm going to subtract 10 from each side. So this becomes 25. This would form a 0 pair. This forms a 0 pair, but now you've got your S on this side. So 25 is less than S, which is this portion right there. And now when we use the other one, we're going to take, and I'll add s to each side again. But this time I'm going to add 10 to each side. So this becomes 45. That forms a zero pair. That forms a zero pair is greater than or equal to s, which if I reverse the order of these becomes s is less than or equal to 45. So your speed has to be less than 45, but greater than 25. When you put those two together, it forms this compound inequality. So yeah, hopefully you just sort of understood this logical part of it. Understanding how to do this part right here, yeah, that's not as easy to do. All right, last problem, I think. Last problem, solving equations. I'm assuming most of you know what to do here, but here you would take away 3 from each side, so it becomes 21 is equal to 3x. So what do you multiply times 3 to give you 21? That would be 7. Here you have to send in the dive bombers, so it becomes 2x minus 12 is equal to x minus 14. I'm going to add 12 to each side, so that becomes negative 2. And I'm going to subtract an x from each side and make that x, so that becomes x equals negative 2. Here we send in the dive bombers again. It becomes 6x minus 9 is equal to 4x minus 5. Take away 2 x's from each side. Add 9 to each side, so 2x's equals 4, which means 1x is going to have to be equal to 2. And here, I think I want to do fraction busters here. I'm going to get rid of all my work here, and I'm going to rewrite this problem. 3/4 of x is equal to 2 times x minus 5. Now remember, with fraction busters, our goal is to multiply every one of these terms times some number that will eliminate our fraction denominators. And our only denominator is a 4. So I'm going to multiply everything times 4. So 3/4 times 4 is 12/4. And 12 divided by 4, 12/4 is the same as 3. So essentially, they just cancel each other out and make 3 x's. Here, this becomes 8 x's, and here that becomes negative 20. So when I take away 8 x's from each side, that leaves me with negative 5 x's is equal to negative 20. So what do you multiply times negative 5 to give you negative 20 for an answer? Well, it's got to be 4, right? Because 4 of those is equal to that. And so that's how we get x is equal to 4. All right, well, another long video. Every video I've made so far since spring break has been over 17 minutes long, and I'm trying to get these to between 12 and 15, so I apologize, but I'm going to do better. Today's lesson hopefully will not be as long, so you won't have to spend as much time on your math. All right. Hopefully you did a good job on this homework and you understood everything, and let's get on to today's lesson. Take care. We'll talk to you in a little bit.
Hey, feeling good, like I should.